Okay, so in this video I'm going to have a look at another proof by induction, and this time it's an example of a proof by induction of divisibility. So we're going to have a look at this expression here, 5 to the power of 2n plus 12 to the power of n minus 1, and we want to prove that it is divisible by 13. So let's have a look at this. So we go through the usual steps in induction. The first thing we're going to do is look at we just do natural numbers here. So we're just going to look at the first natural number here, which is 1, and we're going to have a look to see if we put 1 in here, does it actually work. So let's do that. So we're going to do p1, in other words, p1. So where n is 1, that will give us 5 to the power of 2 times 1 plus 12 to the power of 1 minus 1. So that gives us 5 to the power of 2, which is 25. 12 to the power of 0, which is 1, that gives us 26. 26 is divisible by 13, so P1 is true. So P1, the proposition is true for n is equal to 1. So the proposition is true for n is equal to 1. Okay, so now we do the usual thing here. What we do is we start with we start with our assumption. So I'll just write that down. Our assumption. Our assumption here is that it is true for some number k. In other words, 5 to the power of 2k plus 12 to the power of k minus 1 is divisible by 13. So we're assuming this is true, and we want to prove, the case for k plus 1. So we want to prove pk plus 1 is true. So in other words, 5 to the power of 2 times k plus 1 plus 12 to the power of k plus 1 minus 1 is divisible by 13. So we're assuming this is true, that this part here is divisible by 13, and we want to prove that the k plus 1 case is divisible by 13. So this thing here is divisible by 13. So let's just simplify this here. So here we end up with 5 to the power of 2k plus 2 plus 12 to the power of k. Now, in some of these divisibility proofs by induction, what you would do is take pk plus 1 and subtract pk, but I'm going to have a look at this here and see if I can just do it directly without doing that. So I'm going to see if I can rearrange this, manipulate it a little bit, and see if I can end up with something that is divisible by 13. So let's have a look at doing that first. So let's have a look. We're going to, I'll just change color here. Let's see, we'll go for green, I think. So let's have a look here. This 5 to the power of 2k plus 2 can be split up into 5 to the power of 2 times 5 to the power of 2k. You just add the indices here, in other words, and you'll end up back here. And over here we have 12 to the power of k. Now, that will just give us 25 times 5 to the power of 2k. 2k, 2k here, plus 12 to the power of k. Okay, so we want to see if this is divisible by 13. Now let's have a look. What I can do here probably is just if I go back to our assumption here, our assumption is this bit here. If I can end up with something like this somewhere, I know that this is divisible by 13. That was my assumption. So I'm just going to write that over here somewhere, just to keep an eye on it. What did I say? 5 to the power of 2k plus 12 to the power of k minus 1. Just want to keep that here, because I know that this is divisible by 13. Okay, so let's see if I can include that somewhere in here. Right, let me see. Well, the 20, I need a 13 anyway here somewhere. So what I could do is split that 25 up into 13 plus 12 times 5 to the power of 2k plus 12 to the power of k. 13 plus 12 is 25, so this is exactly the same thing again. If I multiply that out, I get 13 times 5 to the power of 2k plus 12 times 5 to the power of 2k plus 12 to the power of k. Okay, so I know this part here, this is divisible by 13. This isn't obviously yet anyway, or this here, but maybe these two together I can do something with them. So I'm going to leave this 13 times 5 to the power of 2k for the moment, and I'm just going to have a look at maybe this here. I need a 12 to the power of k minus 1. Here I've got a 12 to the power of k, so what I might do here is just leave that there, put in a 12 times 12 to the power of k minus 1. These two together, this is 12 to the power of 1. 1 plus k minus 1 will just give me k here. Okay, so this here is just, if you think about it, 12 to the power of 1 times 12 to the power of k minus 1. You just add the two indices here and you'll end up with k. So you'll end up back here again. Okay, so let's have a look then at what we can do with this. Well, we've got we've got a 12 here and we've got a 12 here. So I'm going to look at factorizing these. So let's see. This is divisible by 13, so I'm going to leave that alone for the moment. I'm going to factorize this. I'm going to take 12 out here, and I end up with 5 to the power of 2k plus 12 to the power of k minus 1. Okay, we're there, I think, at this stage. Now, if you look at these two terms here, we got a term here, and we got this big term here. This here is divisible by 13. We can divide 13 by 13 here, and we're left with 5 to the power of 2k. Over here, we have a 12 out here, which is not divisible by 13. However, this here is this here, isn't it? 5 to the power of 2k plus 12 to the power of k minus 1. This is divisible by 13 by our assumption. Therefore, our entire expression here is divisible by 13. So in other words, we wanted to prove the k plus 1 situation, this situation here, 5 to the power of 2 bracket k plus 1 plus 12 to the power of k plus 1 minus 1 is divisible by 13. We've manipulated this here until we've ended up with this, which is divisible by 13, so we've proven the case for k plus 1. So that's it. That's the hardest part, if you like. All you've got to do now is say, right, well, we know that P1 is true, is divisible by 13, in other words. Pk plus 1 is divisible by 13 if pk is divisible by 13. Therefore, the proposition is true for all n is an element of n. In other words, any element of n here, any n that we use here, whatever n we put in here, this will always be divisible by 13.